Hello everyone. This video will show how to use the right Riemann sum to approximate the area under a curve of a given function over an interval. So let's go over this example here. Approximate the area under the curve of a function, so that's the function that we have right there, and this is its graph, over the interval 3 to 11 using the right Riemann sum with 4 sub-intervals. So what are we going to do first is to label where the intervals are, 3 to 11. So 1, 2, 3, so this will be our A. And all the way to 11, so this is our B. So we are going to determine or to approximate the area under the curve from these two given intervals. So the area under that curve in between these two. So for the right Riemann sum, we're going to partition this interval into rectangles. And the area of all the rectangles under that interval will represent or approximate the area under that curve over that function. We remember that the formula for the area of a rectangle is length times width. So we're going to go ahead and determine the width of each of the rectangles that we're going to create over that interval. So we're going to represent delta x as our width. The formula to find for the width of a rectangle, which again we represent as delta x, is b minus a over n, where our b is the interval that we got here, which in this case is 11, minus our a is the other interval, which is 3, over the n. N represents the number of sub-intervals or the number of partitions that we're going to divide it into. In this case here, it's 4. So 11 minus 3 is 8. And then divide that by 4 is 2. So the width of all the rectangles under this interval will be 2. So we go ahead and draw these rectangles. So we're going to start with A, which is on 3. So I'm going to draw that rectangle. And then again, the interval is 2. So we have 1, 2. So this is our first rectangle. Now notice that our endpoint or the side of the rectangle that should touch the graph should be the right side of the rectangle. The reason why this is on the right, it's because it's the right Riemann sum. And we do the same thing for the next rectangle. The width again is 2, so that's 1, 2. So I'm going to draw another rectangle here, and the right side should touch the graph, and then create that other part of the rectangle right there. And then again, the width is 1, 2, so I'm going to draw that again over here. This side should touch the rectangle, and then create that other end of the rectangle, and then 1, 2. And then again, the right side is going to touch the rectangle and create the other side. So if you notice, these 4 rectangles are touching the graph on the right side of the rectangle. That's why this is called the right Riemann sum. So we're going to determine the area of all these 4 rectangles, and that is the approximate area under this curve from A to B. So I'm going to go ahead and shade this portion down here. So our delta x is actually the distance or the width of each of these rectangle, which is 2. Now, the next thing that we need to figure out is that we know that the formula for the area of the rectangle is length times width, and we already have the width. Now, we're going to find the length of each of these rectangles. To find the length, we're going to determine the height of these. We're going to find the y values. In this case, we're going to represent the y value as the f of x. In this case right here, we have a f of 5. So that would be f of 5. This next dot right here, or this next height, will be f of 7. And this one right here is f of 9. And this next dot right here is f of 11. So what we do next is to determine the values for each of these 4. So we're going to start with f of 5. So what we do is we plug in x, which is 5, into the equation up here. So that is the square root of 5 plus 1 plus 5. So I just use that equation. I put in 5 to the x, and then I'm going to simplify this. So this would be square root of 6 plus 5. We will approximate the square root of 6 to 2 decimal places. That would be 2.45 and then plus 5. So this is 7.45. So that's the height of the first rectangle. Now we're going to do f of 7. So f of 7 will be the same thing. That would be plug in x, 7 to the x. So that is 7 plus 1 plus 5. So this is square root of 8 plus 5. Square root of 8 in 2 decimal places would be 2.83. And then we get a plus 5. This would then be 7.83. And then I'm going to do the rest of the parts here, f of 9 and f of 11. So these are the heights of these 4 rectangles. Now we're ready to determine the area or approximate the area under this curve from A to B. So the formula for the right Riemann sum would be the area, again, is length times width. In this case here, our width is represented as delta x. Our height is represented by all of these values up here, so that would be the summation of our f of x. So in this case right here, our delta x is 2 times the summation of all the x's. We're just going to go ahead and add all these. So doing the math here, this would come out 2 times 31.9, and so the area is 63.8. So this is the approximate area for this all of these rectangles that we have here. So that is how we approximate the area under a given function on a given interval using the right Riemann sum.